Is this good? Okay. Great. Okay. Hello, everybody. I'm delighted to introduce Paolo Manghi. Paolo is a senior researcher in computer science at the Italian National Research Council in Pisa. And since 2009, he has served as the Chief Technology Officer at OpenAIRE. Paolo's research focuses on infrastructures for scholarly communication, research and scholarly communication, and in particular knowledge graphs and technologies that support open science publishing workflows. Today, Paolo will explore a topic dear to EVERSE, addressing the fairness, quality dimension of research software and how the OpenAIRE graph manages outputs, research software outputs, with the goal of helping researchers and research software engineers enhance the visibility, the recognition, and the impact of their software within the scientific ecosystem. And with that, I'll hand it over to Paolo.
Thank you, Stefania. Okay, so first of all, just a quick couple of words to say, well, thank you, really, thank you. This is a very good opportunity. But to say that what we are doing in OpenAIRE has to do with the general problem of tracking what happens in terms of scholarly communication worldwide. So we're tracking events such as I'm publishing a publication, I'm publishing a data set, I'm publishing a software, and I'm citing this research product with this other research product. So we have connections between them. And we're trying to do this by collecting and aggregating metadata from trusted sources, as you will see. So what I'm trying to say is that the level of metadata and metadata description that we have is generic enough to describe all these objects using the very same schema level, okay? So there is this distinction between what we do and what EVERSE is doing, which instead is trying to dig into very specific metadata description, dig into fairness definitions that go beyond the one of the fair maturity model in RDA. Okay, so get prepared about this. On the other hand, there's an overlap, of course, because again, these information models are very different, one being very specific, one being very generic, but they overlap, okay? And in some way, as you will see, they can give us a hint or where we stand and which could be the directions, okay? So, first of all, OpenAIRE graphs, the basics. It's a scientific knowledge graph. It means that it's a collection of metadata describing entities in the research domain and how these entities are connected. So it's supposed to be timely and comprehensive, the coverage, meaning that we're trying to collect from all trusted sources out there, those knocking at our doors, and in some cases, those that we believe must be in and they should be there. So we're trying to make it as much as possible aligned with the reality in this very moment. We generate it every month. So we care a lot about precision, depth, and processing of the data. So we clean it. So we clean it according to a core model that is based on standards, plus something that we added on top. We deduplicate it. So the results of the graph are deduplicated. So you will not see the same objects collected from different parties appearing multiple times. And the same happens for the citations. So we deduplicate also the citations. And where the metadata is not enough, we apply full text mining. So we have a full infrastructure to download PDFs. We have many agreements with the publishers and so on. We are reaching today 70 million PDFs, and there we apply full text mining algorithms trying to extract the metadata that is not made available by the researchers or by the systems that they use to publish their research products in many cases. Don't be surprised, but many of these platforms are very old, like 20, 30 years old, definitely not aligned with the current standards for scholarly communication. In some cases, they're not aligned with some systems like ROAR or ORCID. So what we do is our best to enrich this data. And of course, everything is run on professional infrastructure in Poland it's a quite big infrastructure, and it requires not just machines and iron, but also skilled people to operate it and make it operational on a 24/7 basis. Now, if you want to know more, just go to graph.openair.eu. You'll find more information. This is the information model, I mean, from the moon, maybe from Mars. Okay, so of course it's more detailed than this, but that's just to give you an idea. So the core, at the center, we have what we call the research products, which can be publications, data, software, or other stuff. Publication is anything that is published with the purpose of having a user reading it. Data, it's everything that is published in support of science in that sense, or as a result of science, and is supposed to be subject to processing in general. So it's informative data, and software is code. We classify it as code. I'm fully aware of the fact that it's not easy to understand what software is, and there are many definitions, so we are being very elastic here and flexible, but in general, it is code. Okay, so we're not, for example, a tool is not considered software, but the software of the tool is considered software in our domain. And then there's other. Other is meaning anything else that we cannot classify according to the first three. And this may be the case for some very subject-specific or domain-specific kind of output. Although in some cases, of course, we ask the communities on where they want to classify their stuff. And because when it's about data and research data, it's really hard to have a clear classification. For example, the life sciences want proteins to be research data. Okay, so we haven't complained about it. It's up to them. Because whatever is part and described of this information model can be reused for monitoring, for discovering, research assessment, and many practices. Then we have persons, and for persons, we are using heavily relying on ORCID IDs at the moment. We have the data sources, so we track every collection, a data collection from every data source that we have. We have projects, and with projects, we also have funders. So some funders give us the projects at the level, the granularity of the grants, basically, and we connect it to the research products. And of course, we have the organizations with which we build affiliations, participations to projects, like beneficiaries or services and provider of the services and so on. And of course, citations. So we are tracking all possible open data citations. We are calculating open data citations and citations between all kinds of products. So it's not just about publication, but we care about also publication software, for example. Then other entities will come into the picture soon, probably in 2026. Will include services, tools as different from software, potentially linked to software, or special kinds of objects like methods and models. Now with the AI, these are becoming essential, and often they're published explicitly as such. And then we want to add to services and tools, facilities and instruments. Many are working in this domain to make more clear what they are and how they're functional to science in general, so connected to the other. Again, the objective is to be able to monitor science as a whole, according to COARA, according to the open science practices, monitoring open science itself, and so on. So it's the unique features that we can track when compared to other graphs or similar graphs out there is that we have an open science data source coverage, meaning that we are collecting also from sources from the research infrastructures, from the data domain, let's say from the software domain and so on. We therefore go beyond with product typologies. So we care a lot about fine-grained bibliotyping, meaning that we make a distinction between an article, a chapter, and the thesis, or a deliverable or a report, and we're not just classifying them as articles, right? It's just as one thing. We deduplicate citations, and that's again something that I want to highlight because it's not obvious. In many cases, when you collect, for example, the same article from multiple times and you infer the citations from both versions of the article, the result is that you may have the same citations proposed multiple times in the same graph. We are in fact resolving this problem, which is not an easy thing to do, so I'd like to highlight it. And then a key thing is that we keep repositories and community in the loop. So that's a key thing, which we believe is very important for open access, for open source, open science graphs like the ones that we are defining, because these graphs are not there to persist information. So we don't want to make the same mistake we did in the past with Microsoft Academics, with Scopus, or with Elsevier, Web of Science, where we are delegating somebody else to keep the information that is important somewhere there in a graph that we have to pay to access for. So what we are doing here is to collect data, and every time we have new data, fresh data that was missing at the original repositories or data archives, we give them the chance to take it and store it where it should be for the future and for other graphs to be built. In that sense, we're also engaging with the researchers in improving the way they're publishing, or aligning on the way they're publishing, in order to facilitate the process to graphs like ours to build this monitoring collection, these over comprehensive collections. And at the same time, we're helping building open data collections that can be functional for the constructions of graphs like ours. In one example that I'm reporting here is OpenAIRE, which is a service that we provide. We're engaging with hundreds of users to clean up organization information in Europe and worldwide. This is an open data citations that, of course, we use a lot, but others can access and reuse whenever they want. So it's very important and key for the communities to be there. Policies, standards, interoperability standards are not enough, okay, to complete what we need to do. So take scholarly communication in our hands as a community and not outsource it to companies that make money out of our known knowledge. So this is how we build a graph. I'm going to fly on this slide because it may take too long. But we are collecting from sources. As you can see, there are two main classes on the left side. We have the onboarded data sources. These are the data sources that comply to the OpenAIRE guidelines. The OpenAIRE guidelines are the result of a community effort that was, let's say, supported by OpenAIRE, that included communities like CORE, so the Coalition of Open Access Repositories, the platforms like DSpace, Dataverse, ePrints, and so on, in defining which is the best way to export the data. Okay, so the community decided to go for DataCite with special vocabularies provided by these communities, again, not by OpenAIRE, and use the OAI PMH protocol. The reason is because it was a compromise between the extent, so what platforms can actually do today, because you may come up with a fanciest new protocol, but nobody's going to implement it because it costs money. Most of this platform, I would say 90% of this platform, are run by organizations, institutions, academic institutions, and research centers who are not investing loads of money in operating such systems. So it was a good balance. So from there, we are collecting metadata, and we facilitate this process through OpenAIRE Provides. So you go, you register, you validate your repository and your metadata export using our tools, and if everything goes fine, you're into the system. So you access your dashboard, you have all possible information, how to enrich your local metadata, as I mentioned before, using the OpenAIRE broker, how to access user statistics like views and downloads. You can be part of this infrastructure that we build that is called usage counts, where we track all the events of users accessing your platform to view or download objects. We collect all this information and we aggregate it centrally. So if the same object is viewed or downloaded across different repositories, we know that because of the same persistent identifiers or the deduplication process that we have. We provide aggregated information about it. Then we have at the bottom the instrumental data sources, and these are, of course, essential, again, trusted sources that we use in our daily life, like Crossref, DataCite, PubMed, Archive, ORCID. We are ORCID members, of course, and many others. Okay, also research centers with which we collaborate that are giving us ways to enrich the data, for example, sustainable development goals and so on. We give them all the visibility. We have very strong relationships, memorandum of understanding, in some cases contracts, and we bring in the data together as a community again. We're collecting today from 2,000 data sources indirectly, because some of these are aggregators, 150,000, okay? So we first aggregate, that's clean data, then we enrich it by mining the full text, as I mentioned before. We have, I think, 15 different algorithms that are extracting citations, relationships of the ones that you can see there, publication project, publication data, and so on. We deduplicate after that, so we bring together different versions of the same objects in OpenAIRE. Preprint and postprint go together because they are the same research effort and should be counted once in terms of research assessment. Then we enrich again by inference, and that's another very nice process because we propagate, since we have a graph, from one object to other objects information that may be interesting. For example, ORCID identifiers. I have a very nice publications in this journal with all the ORCID IDs that is supplemented by a data set which has very poor metadata. And we have inferred that is paper because we mine the full text is linked to a project. Okay, so what we can do is to take the project link and the ORCID link and pass them over to the data set because it's supplemented by given certain conditions, of course, if the same authors are there, etc., etc., etc. So this propagates information and enriches the overall monitoring tagging that we can provide. Then we finalize it and we provide it to the world. Okay, so we have an index, we have an API, several portals that you can see. Our portals are Explore, which is a generic search where you can search for everything or browse for everything and so on. We also have Connect, and Connect is a way to provide Explore, a tailored Explore to communities. So we can give you access to a number of tools through which you can select the criteria of inclusion and build your own portal on top of all the data sources that we have, taking into account the projects, taking into account the SDGs, the fields of science, so you can tailor it. We have, I think, 100 of these for different communities. And then we have Assess, so a number of portals that you can provide, and again, tailored for monitoring. And there we provide all sorts of statistics. Score, open access score, open science score, usage of fairness, Plan S, transformation agreements, usage statistics, all tailored to your own production, because we want to measure your impact, where you can be a research community, a research infrastructure, an organization like a university or an alliance of universities, or a country. We offer it to ministries, for example. We offer it to Ireland, to the Netherlands, to Greece, and now to many others that want to have access to those. And then we have other services like Argos and so on. What is important here is that we take all this info, we send it out, but we involve the communities in it. Okay, so we want to improve by sending back the data to the data repositories and institutional repositories and so on. So you can, as a repository manager, get all this info, or otherwise you can participate to this campaign of data curation, where we together, and we give all the visibility to the authors of this curation, build open collections like OpenORGs to improve what we have. At the same time, for the cases of monitoring, for example, we do it for funders, we do it again for organizations. We have a constant revision of the algorithms and the fine-tuning, trying to understand where we can improve with the algorithms and where the community can improve. For example, if we find out that a repository misses ORCID identifier in the 50% of the cases, we can highlight this and strengthen the policies of this organization, for example, to improve the quality of the metadata from the users. So we giving back the support. Few numbers. At the moment, this is this September graph. I took screenshots, and it was easier. We are producing now the October one, where of course they are higher. You see there's a general increase. We are counting 200 funders, and as you can see, a number of projects, which is covered by the pictures. Okay, 3.5 million. For each of them, we mine all the PDFs to find a link. And then the rest. As you can see, and here is the first start, is the first glimpse, software suffers a lot, okay? And we can see that. So software is published software that we are aware of, that we collect, is a percentage that is really minor compared to the rest, compared to the research data, compared to the publication, okay? Let's dig into that, okay? So coverage, we are collecting from PID registries and curated collections. As I mentioned before, these are instrumental data sources, and these are examples just for you to take a look of what we mean. So institutional repositories, thematic repositories, catch-all repositories like Zenodo, aggregators, catalogs, etc. So Latin America aggregators and so on. So what is the scope of research assessment and why it differs? First of all, is because compared to the past, where we were interested only in publications, we had very few input data sources. So we had Crossref, we had maybe PubMed, Archive, a few others, that's it. So super control. Today here is crazy what we have. We have a huge amount of repositories out there, which, as you will see, are not fully under our control. Not all of them have gatekeeping, peer review. Not all of them have community endorsement like Archive. You can just go and publish, Zenodo, okay? We have so many different additional resource types to manage. So it's not easy to construct a graph like ours, but it's not easy also for the community to understand how to behave, what it means to publish, okay? So this is what the graph is today. So it's community governed and et cetera, et cetera. So data sets, software, project grants. So there are many nice things, okay? On the other hand, it's clear that building this graph, we need to involve the community because the community really is lost in many ways. Some communities are more, let's say, driven by policies and common guidelines, others are not. And with respect to software, and software is the kind of product that you can find everywhere in all domains, we are getting really lost, okay, as you will see. Main challenge, metadata curation. Heterogeneity of resource types, as I mentioned before, so we don't really know. Different repositories have different vocabularies. It's really hard to, for some, for example, publishing a software means to publish it as a data set. There's no other way. So these are blurry resource types. And this leads to inaccurate and untrusted metadata in general. In some cases, also the question, is this actually research software or is it a software for research? Does it qualify as such? It's not easy to answer in many cases, okay? So just to give you an example, this is a super fair document in OpenAIRE, in Zenodo, okay? As you can see, it's just a try. It's a journal article, open access. The title is uploaded data. The abstract is I failed to upload it the first time, so I upload it again. And the author is an author, okay? This guy or this girl, I'm not sure, apologies for this, may have provided also an ORCID ID at some point. So how can we, on our hand, as graph builder, improve this? It's not easy. The same is for bibliographic typing, okay? In some cases, the problem is in the platform. So you upload something in a platform, you give it a resource type which is precise. In this case, as you can see, this is a news, NCO news, but then the platform exports the metadata, mapping into a model of reference in the wrong way. So as you can see, this is mapped out as an article, okay? So again, I'm exemplifying this because we really need to involve the community in what we're doing before we define the policies. So this is again another example, okay, on how the policies fail. So article is a good example for us. It's a good resource type, but it's mapped in the wrong way, okay? And we cannot learn about it. And in some cases, there are resource types that are so blurry, like conference objects. Conference objects may include presentation, may include all sorts of stuff. It's like data sets, so it's generic, okay? And people use them because it's easier, because they're not instructed on how to do things properly. At the end of the day, it's really hard to understand. So this one is a paper, but we don't know. We know it's a conference object, okay? So how about research software? Let's dig into it a little bit. Again, super lack of gatekeeping. In general, the most used platform is Zenodo, and I'm saying all with this, with exceptions of a few communities defined in Zenodo. So the concept of community in Zenodo embeds the notion of metadata curation. The rest publish software in Zenodo using common sense. So common sense is the rule, right? In some cases, they just use it to get a GUI of something they published in GitHub, and that's a classic. But the lack of gatekeeping in general brings low fairness, inaccurate metadata, pertinence doubts, as I mentioned before, and heterogeneity of resource type. Is this software at all? In some cases, it's really hard to understand. For example, if I'm publishing from GitHub data, people can have data in GitHub. The selected resource type is software. Okay, so you need to be clear. Okay, and again, this is about practices more than metadata standards. So I'm inviting you as part of this project to clarify and give a strong flavor, a strong argument to this. Defining metadata formats is not enough if you have people that are not trained to use them in the proper way. And you should make it also very simple. And that's another thing that is not obvious, because publishing in general is a tedious process, and the scientists want to do it as quickly as possible. So if you show them, for example, a vocabulary of 100 terms and under it another 200, they will pick the first that makes sense, not the right one. Okay, and that screws everything in terms of your mission. There are a few dedicated publishing venues, and that's the other issue. So we don't have a place where we publish our software. We have GitHub, which is where we maintain it and so on, but that's not publishing. Okay. And we have places where you want to publish it, so where you care about attribution and all these aspects. And we know that there is a connection between the two, and this connection can be built using CFF files, code meta files, but this is not happening today. So the result is that we are collecting software from different places with different hints. Many use software repositories, as I mentioned, and it's not possible to go to a GitHub and ask, which is your resource software? You can only collect everything with very poor metadata. Stats show that I think it's 2% of software in GitHub using CFF files or code meta equivalents. Many use catch-all repositories and institutional repositories. And cross-discipline common interpretation, like code tools, methods, applications, all these are different types that you may find out there. In some cases, however, you also have these generic types that I mentioned before. So it's really hard to align those different vocabularies into one. It would be great to have a very nice definition of what the research software is, and a very nice classification, which we could all refer to. But given that, existing repositories do not use it. Okay, so that's the main issue. And mapping their locals onto yours is not easy. Okay, let's go. So the good news is that software publishing is increasing. We have a 75% of open access software in our system. The rest, it's either restricted, closed, but a very minor part, like 5,000, or unknown. In general, where it is unknown, it's open source, but we cannot say so. Okay, we cannot claim it. It's just not provided. The license is not provided. So as you can see, there is an increase over the years. It's a clear increase. Okay. These are the main sources from which we find or infer software, as you will see. So we're not collecting from GitHub. We are inferring from PDF links to GitHub. Okay. And these are the numbers that I showed before. Okay, it's from September. Now, what is interesting? Citations of software. That's another interesting output, because we have out of this 700, almost 800,000 software, 1/4, so 222,000 are involved in citations. So they're being cited either by another piece of software or a publication or a data set, as you can see below. Okay. So we have references from publications to software, which we mine. So we mine into the text for URLs to GitHub and so on, but we also mine for DOIs to software, etc. So we build and we reificate these citations. We also find them between dataset and software. presumably and mainly from DataCite when these are available. It would be really interesting to have an in-depth analysis of this dataset, because a dataset may be the wrong type. Okay, so that's the other thing that we don't know. It could be a publication. You see other versus software, for example. These could be publications. They're just mistyped and we cannot find the right one. This is an example of a very good research software, how it is published with a DOI, a venue endorsed by the community, good metadata. It has a link to GitHub, which you cannot see. You see, these are the views and downloads in Zenodo that we can collect, of course, centrally. That's fantastic. It's provided by the Escape OSSR, which is a community on top of Zenodo. Okay, these are good common sense examples. For example, this is the one on the left is published on our institute at CNR. So we are collecting this metadata from the institutional repository. As you can see, it's really well done. It does not have a DOI at the moment. Okay, the one to the right is the classic export from GitHub to Zenodo. So Zenodo generates a DOI, and the person, Ben, spend time to complete the metadata. So make it nicer. Okay, these are instead nightmare examples. So this gracefulness, I would say, to get a DOI. So they just get a DOI with nothing in it. So this actually is a metadata record of a software that is completely useless in many ways. So it's unfoundable, basically. Okay. And this one to the right instead is a very bad way to publish software, because they get a DOI, but they type it as a dataset. So this is clearly a piece of software, okay? But the typing provided by the users is wrong, and probably it's not their fault. It's maybe the repository that does not have at all the software typology as an option. So what we do in OpenAIRE is, as I mentioned before, we try to link it. So we do two actions. The first one is inferring the URLs from 7 to 8, I don't remember, classic repositories. We build a record out of it. So we fetch the metadata from the repository. We try to do something like orienteering problem software on GitHub is something that we add, and we create the relationship to the paper. So this actually gives the possibility to the person visiting the paper page to link it, to navigate to the piece of software, clicking on it, going to the GitHub, okay? Without visiting the paper or copying anything from the paper. You can do it from our portals, and it's nice statistics. Still, as you can see, the information there is rather poor. What you can do, what we also do, however, is to take these URLs and check if they are in software heritage. And when this is the case, we also include in the record the software heritage pointer. Why? Because we want to have it persisted forever. So this piece of information should not take you to a GitHub that maybe tomorrow will no longer exist, but to software heritage. So make science from this point of view as persistent as possible. So we are providing for this by interacting with software heritage. So this software that I mentioned before, this is the list of software that we can find also from software heritage in the graph, so for which we have a link. And as you can see from this, you can access to the piece of software, okay? And this piece of software appears in software heritage and also in GitHub, from where we found the first link. We can go to the related research. As you can see, there are 15 papers that are referring to this URL. Now they're shown here because we rebuilt the collection, so you can click on the paper and visit the paper, okay? So this is all done through the graph, and these pieces of information, as well as the relationships, are made available. Quick view of fairness of software for resource products, software resource products. So peak coverage, that's an interesting one. Out of the 800,000 that we have software products, 400,000 do not have a persistent identifier, okay? And the rest can be split as follows. So 376,000 have at least one with a subsequent distribution. In some cases, we found duplicates, so they show multiple persistent identifiers. And this is the distribution of the persistent identifiers out of the 730,000 persistent identifiers that we have. This is the distribution. Take into account that in many cases, the same software may have more than one persistent identifiers, especially if it's uploaded in Zenodo that generates a new DOI for every new version, okay? So this is why the numbers here do not match in that sense. Okay, so the DOIs are many because there can be more than one for an individual object, okay? So there is a trend towards a bias towards DOIs in general, but still many of these are not effectively published, but identified by our mining, okay? And that's not good in general. Here, I try to go a little bit beyond. So I run an analysis on the graph and how to read this table. Every time you see a letter, it means that the letter is there, okay? So it is there, and the rest is not. So this is crucial to understand. So T means records, software records only with the title. So this means that there's no date of acceptance, no license, no abstract, no persistent identifier, okay? This is bad as a number. The fairest of them all is the second. So where you have a PID, you have a title, an abstract, a license, a publishing date. And as you can see, the percentage is not super high, okay? That's the way I read the table, at least. So again, it's not super appealing, but it shows an increase over the years. It would be nice to cross it with improvement over the years. But every time you see PTALD altogether means that there is a user behind, okay? It's not machinery and there is an attempt to publish things properly. So you can reuse this slide whenever you want. You can access all this data through many channels. So REST APIs, open data sets in Zenodo that we publish. We also have a beginner's kit that allows you to get started with the interaction with the data and do your first analysis. We also have a Google Cloud Data Analytics environment that you can access. You can find all the information at the graph.openair.eu, okay? docs/docs for the documentation. And thank you. That was the last slide.
Cool. Thank you very much, Paolo. Thanks a lot. Let's open the floor for comments and questions, reactions to these numbers. Raise your hand or write in the chat. Jason, please.
Yes, thanks for this great presentation. I was wondering during your presentation, and this probably makes your life even harder, software tends to have versions, right? So there's often not just one version like you would have with a publication, but there's multiple versions. Now, of course, if you get data from Zenodo, typically different versions have a different persistent identifier. But if you do text binding on papers and people are actually pointing to GitHub repositories, for example, you lose a lot of information about the versioning. So have you thought about how to actually solve this issue?
Sorry, I was muted. Okay. First thing, we consider an object to be the same. Oh, okay, so hey, hello, Danny. I didn't know you were here. So we consider an object to be the same, so a research product to be the same in the graph with different criteria. So it depends. We're not applying the same criteria to publications, to data, and to software. So we are more or less tolerant, and we try to fit with the specific object requirements, at least that we have found. In the case of software, we are slightly tolerant with respect to the version, but we're not tolerant with respect to the authors at all, as we do for the others. So for example, if you have a new version of the software that involves different authors, these are not going to be the same object, okay? So, and that's key. The second part of your question, I guess, is whenever we find a link to a URL, the URL corresponds to a record, and then the record is subject to this deduplication phase, okay? So it's not really up to us. So if the URL that is specified is not referring to one of the specific records of the version, there's nothing we can do. It will basically fit with the best match, okay? Because we use the URL as an identifier, as one of the possible identifiers, okay, for software. We don't do the same for example, for publications. Danny? Jason, is this enough, or you want to elaborate more?
No, I think it's clear. So,
Okay.
and you could even complicate it further in the sense that people could also have points to repositories, right? So that you have something in I don't know, PyPy, Maven, pick a software repository or package manager, I should say, where indeed that's also an identifier. So it's a complex
It
subject.
is.
Yeah.
It is, and you may understand from our side, we just get information. And as I mentioned before, the key thing is how users provide this information that makes the difference. So they should be aware of the fact that it's not enough to put something out there using common sense. We're all clever people, and our common sense is always right, but it's misaligned by definition. Okay, so and this is the problem we're facing in some cases. Danny.
Right, thank you for the talk. So you were saying that defining software, it's kind of a challenge, right? So I was wondering, how can we actually, as the EVERSE project, help here? Maybe there is something, because we were categorizing software in 3 different tiers, right? There is like analysis code, prototype tools, and infrastructure software. So I was wondering if this sort of classification would be useful for OpenAIRE, or whether maybe you'd like to engage in kind of defining what is it that you consider research software, because at the moment, if I understand correctly, this is done manually by authors, no? Like someone, when they publish, they decide whether this is research software or not. And I think that automatically everything that comes from GitHub, whether this is a presentation or I don't know, data and so on, it is automatically tagged as software. Am I correct, or is this different?
It's a combination of truths. So, yes, so when you upload, first thing, when we infer a link to GitHub, for example, from a publication, yes, you're right. So we tag it as software, okay? And that is bad, good. We don't even know what's the percentage there, okay? We just assume that this is the case. I'm not 100% sure, but I don't think we are trying at the moment to visualize what is around the URL. Okay, so we just take the URL. Then there's a second action that we're working on now, is software mentions, which is a different dimension, of course. And it would be great to combine the two, but that's a different exploration. When a user is uploading a software from GitHub to a repository, they have a chance to make things differently. So they can, okay? Then to your question, is it useful to have a classification? Of course it is. It's always useful, especially if it comes from a community as strong as yours. But it opens up a challenge. Let's say I want to adopt this classification, which I'd love to have, because today we don't, okay? So we don't have it. So it would be nice to say a software product can be of these 3 different categories. Great, that would be fantastic. And maybe you have AI models, and maybe, I don't know what's your classification, but something that is very useful today. It's useless unless you provide me with ways to understand how to map current practices of bibliotyping software onto this, because this is what the graphs do, right? So we can elaborate together any sort of algorithms that does best effort algorithms that do the best to remap whatever is out there, even a combination of metadata fields into one of these, that would be great. So we need this combination of things like criterias or identification of practices or patterns. And then the other level is to go to the original sources, go to Zenodo. You should knock at the door of Zenodo, which today stores, I think, the 85 or 90% of software with a persistent identifier in the world, right? And tell them, please, are you willing to do this and that? And this could be an important thing for the future. So when we define the OpenAIRE guidelines, we just, with the community, we involve the platforms. We involve all the platforms like we did in our project, Danny, because that's the way to make sure that the practice becomes useful. Defining the standards alone and by themselves is not enough. I mean, even today, I mean, if you tell me this vocabulary and then I go to my institutional repositories, what can I do? There's nothing I can do, right? So it's actually very important to combine a number of elements. So as EVERSE, build a universe around it. Do not focus on vocabularies, but focus on the challenges behind the adoption of a vocabulary from a community, from the monitoring perspective, etc., etc., etc.
Yeah, I think this is more or less what the focus that we have, right? We are not defining vocabularies or indicators. We are just using the ones that are defining the state of the art. That said, it is always useful when, you know, also a big player adopts or claims that it's adopting certain thing, because then it's kind of with what happened with the CFF, the citation file format and GitHub, right? There were none. And then after GitHub adopted CFF, then people are starting to add it because they get this small window where they can copy the citation from GitHub, right? So sometimes it's just not, one thing is not possible without the other, no?
No, it's definitely true. We are certainly interested to do so. And we'd like to do it, however, with the idea that something is doable already today, because adopting it without any side effect is useless. So we be more than happy to say, this is the community suggestion recommendation. We are adopting it. Let's put it in beta. Let's see what we can do to map the existing vocabularies onto that. So this is something that we can share with you, Danny. For example, we have all possible terms used by all possible repositories out there to classify their objects, right? So identifying which subset of this fits with the notion of software and how this could be mapped onto one of the classifications you have in mind would be fantastic, right? So that would be an immediately a very good kickstart of adoption in the system. But having it there with 0, 2, 3, 4 elements, it's not helpful. So we need to, yes, I'm more than happy to work on that. So are you doing anything, that's a question for you, on the AAI models and all these kind of things? Are you classifying them as software? Do you have an idea of how to highlight them or point them out with respect to the general classification, or are they just one of the subcategories of the organizations that you mentioned?
Sorry, is that a question for me in particular or a question
For
for
EVERSE.
everyone?
For EVERSE,
For
yes.
EVERSE.
Because we were thinking, as you can see here, you see, models could be, because they're becoming more and more important, either a special subtype of software or one of the main entities. We should be careful. For us to have a main entity, it's a major change. Foti, go ahead.
So I have two responses. I'll start by responding as EVERSE that we are not looking at AI specifically. That's the formal response, and I'll leave it at that. With my non-EVERSE hat on, I've relatively recently learned that, legally speaking, the Commission, AI models are classified as software, which when I learned, I was extremely surprised. Not a special kind of software, it's software. Which I was really surprised, and I already starting to push in the direction of like, you need to change that definition. But for the time being, any kind of legal documents that are currently in the Commission define AI systems as software. And under AI system, they have from models to the workflows that create the models and everything in between. So it's very general. My argument using the RDA hat on, and I'm sure Daniel can agree on that, is that an AI model is neither data nor software. And it's not a subcategory of either, because they do have characteristics that are similar to both, but because of how unique they behave, especially looking about supervised models, and it's not that easy to classify them under either or. So if it were up to me, and I fully understand that this is a huge complication, I would argue that this qualifies as an additional type. But again, that's just me. And I'll shut up now.
No, I think we are aligned. I'm willing to push it as a first level entity. I'm just asking you guys that you certainly have a better ideas than me. Jason?
Yeah, so I would like to point out here that the models itself is also overloaded term, right? So I work a lot with people who are actually the traditional field of modeling. So they model diseases spreading, or they model pollution going through the environment, those kind of things. And they have a very different concept of what a model is. And they typically see a model as a superset of software. So software is just an implementation of the model that you have sort of theoretically created. And then you have the software that actually implements this. There could actually be multiple implementations of this, but you also have all kinds of knowledge related to, I don't know, sensitivity analysis, those kind of things. And all of this together is actually the implementation of the model. So just to, well, further complicate things, there is an entire, there are multiple fields out there that have a very different concept of models instead of AI models.
Daniel?
Yeah, I agree. I mean, I've worked with economists as well, and their models are spreadsheets, right? And some people would call that data because it's a CSV or an Excel file, but it has some rows that perform the equations, and they are modeling a full scenario in a spreadsheet. So maybe just to avoid any potential issues here, I would, instead of models, I would put AI models in this slide, and you would avoid all this problematic. And I agree. I think that AI models in particular would be a kind of software, even though some people could consider them as trained data as well, because, well, the model has been trained with a lot of data, and the data is kind of part of the model. It's just a series of weights and whatever. But overall, when you describe a model, you would talk about it as if you were going to run it, no, or run it over certain new data and so on. So I think it would be classifying it as a new type. I would agree that is maybe a little bit more specific that general software would be appropriate. We are we we are talking a lot about this in the FAIR for ML working group that Fotis is leading as part of the Research Data Alliance, and well, we can share with you also some of the conclusions that we have reached if you are interested.
Yes. What other things that could be done, as I mentioned before, is if you want to make this actionable, let me see. So let's assume that we introduce AI models, okay? So how can we identify these models? How can we make sure that there is something that we can call an AI model? So in the graph, so be genuinely classified as such, okay? So take a look at this. I'm not sharing now.
But quickly, Paolo, please, because we should wrap up.
Okay. Well, this can be taken, of course, offline. I mean, it's something
Yeah.
that, but if you run a search like AI model, okay, on Explore, you see there's many things that match this definition, especially if you restrict to research software, okay? AI hybrid model, AI hero hackathon, I'm not sure this is the right one. So it would be nice to find ways to retype or recast a type over this as an attempt, right? Of course, it's always an attempt, but it would be very important to try and doing it. So to see if there are practices that users are adopting without even knowing, right? To suggest that what they're publishing is an AI model. And if we can use such practices or identify them automatically to provide the right tagging. Because this is what is actually missing. And the addition is, now that you have it, can you go back to your repository, for example, and suggest to include this kind of classifications so the next time you do things right? This is not obvious, again. So as I replied to Danny, I'm super in favor of adopting categorizations as long as they come with also solutions to remap or recast or retype what we have today. So to make them useful classifications, and happy to work together on this. So I'm not sure if there is room in EVERSE for this kind of activities, but I'd be very interested.
Okay, thanks. So
Thank
it's
you.
noon already in Central Europe. And before closing, just Eleonora would like to make an announcement.
Yes. Yes, thank you, Stefania. We are just very happy to continue this webinar series next month with a training focus webinar. The focus is going to be this time on the research software stories. That is a tool that we are using in EVERSE to bring closer the science clusters, the science communities in general to the work that we are done in EVERSE about everything that has to do with quality of the research software. So that the date is going to be announced soon and through all our communication channels.
Excellent. Thank you very much all. Thank you, Paolo, for participating, for presenting, and everyone for your comments and questions.
Thank you.
And
it was very interesting.
See you soon.
Ciao.
Next.
Bye-bye.
Bye.
Say,
Bye. Bye.
bye.
Thank you. Bye-bye.